Bonjour. I'm team lead data science scientist in Safran Analytics, and I'll be talking about data science at Safran. There was a time when flying was just a dream. Can you imagine the excitement of those first pioneers, the ones that built the first working prototypes, seeing their creation fly, seeing the dream of mankind realizing? Can you imagine the excitement of realizing what was thought at the time to be impossible? So this was a real revolution, and it all happened not very far from here. So some of the most important pioneers in aerospace worked here in Paris, right? And it was a revolution because it changed our notion of distance. So something that a travel that would take days, now in just a couple of hours you could go in very, very distant places. It was a revolution. Now, fast forward 100 years. So we seem to have managed, so we master now the science of flying, but these pioneer spirits, they remain. Because right now, we are in the middle of another revolution. It's the digital revolution. And I'm here today to invite you to join us at Safran in being a pioneer in this revolution. And because I'm inviting you to join us, I'm going to tell you a little bit about who we are. So who are we? As you can imagine right now, we are an aerospace company. So we have business in aviation, space, and defense. We are an international company, large one, market leader in many of the areas that we do business in. We build this and this. We also build this. And we are, with our products and services, we are here and here and here, and in many other places. When you travel, when you do a business trip, when you go meet someone that you love. So we are with you. You see, internet companies, they claim to connect people, but they do that virtually. Because we build flying devices, and we also connect people, but we do it for real, right? Face to face, full contact. We bring people together. And we've been very successful at that. So this graph shows the number of travels over the years, over 50 years. And you see that's almost a perfect hockey stick graph. So this growth has been exponential, right? And we've been successful because we are in a growth market and we have the right products. But of course, we have challenges associated with these. Our challenge is to keep this growth going. You see, everyone wants to fly. I want to fly. You want to fly. Demand of flight is not a problem. The problem is access. There was a time in which only the rich could fly because it was expensive. And nowadays, it's possible for me, you, most of us, to fly at least once a year. We do that often. So our challenge is to keep this growing, right? To offer access to more people, to fly to more places more often. That is our challenge. And how do we accomplish that? We accomplish that by creating efficiencies. And this is where the digital revolution comes in. By creating efficiencies in our supply chains, in the way that you produce products, in our services. So let me give you a few examples of efficiencies that can be created via the digital revolution, via data science. So let's start with manufacturing. Imagine assembling a product as complex as an aircraft engine. And not only assembling it, but manufacturing all the parts that come together in this product. And because everything needs to fit perfect, and not only perfect, but reliably. You need to trust our product. When you are flying there, you don't want anything to go wrong. So you understand that when you produce a part, we will check, and then we will check again, and we will check as many times as needed to make sure that everything is correct, the quality standards are met. And we will not only check at the end, we're going to check at each step of the way. And each check may comprise thousands of measurements. So you get the picture, right? So we go through this process, but it's absolutely necessary, but it costs time and money to do all these checks. But increasingly right now, during the production lines, we have data of these measurements flowing towards some large database. And here's the question, and here's the challenge. Right? Can we speed up our production line by optimizing this check? Of course, while keeping the quality of our products the same or even better. Can we do that using the data that we collect? Can we quickly find where quality problems come from? It's a fact of life. Sometimes you produce a piece, a part, and you check it, and it's not up to standard. And that's a fact of life. But if this happens often, systematically, we receive a call in Safran Analytics asking to ask for help. And instead of taking days or weeks, can we do that quicker by using this data? So that is a challenge that I have for you. Now, if you have a good answer to these two questions, I'd like you to stop right now what you're doing, grab your cell phone, and go to this website here, right, and look for jobs at Safran Analytics, data science, and apply for it, because I want to hear from you. So this is examples of challenges that we are dealing with and facing, and we need your help for that. We need your talent. Another example of how to create efficiencies in aerospace, services. Everything that goes in an aircraft needs at some point to be serviced, maintained. Everything degrades. Now, when a critical component of an aircraft engine needs to be serviced, you have to put the aircraft away, which means loss of revenues for our clients, for the airlines. Luckily, you can reduce this impact very much if you can plan ahead. So that's why we work very closely with our customers. We give them a call and make them know that they should service certain components, let's say, every 1,000 flight hours, right? So some reasonable interval that we know. The problem is, sometimes there is the degradation of the parts at times before they are planned to be serviced. And again, this is also a fact of life, right? Sometimes the unexpected happens. And when this happens, and it's critical, the airlines, they don't have much opportunity now to plan ahead and service that component on the engine at the best time. So they need to do it immediately. And the question is, can we help airlines identifying these problems before it becomes a flight delay, before it becomes a flight needs to be canceled? That's the question. And how can we do that? Which kind of data can we use? Now, there was a time in which an aircraft engine would produce only two outputs. Was movement forward and condensation backwards. So this beautiful white trail that you see in the skies. Nowadays, an aircraft engine produces three outputs: movement forward, condensation backwards, and data, and lots of data. So this is just the estimation of one of our products, the LEAP engine. So we expect in the future these engines to be producing 32 terabytes per day of data. That's lots of data. And again, we need to go through this data to identify signals that predict degradation and maintenance needs. And we need you to help us in this. Data science has a very important role in making sure that these efficiencies or inefficiencies are explored. Can we reduce downtime caused by unpredicted maintenance? That's the question. Now, it seems like a job for a data scientist, right? So what is the job of a data scientist at Safran then? So let me try to paint a picture for you of what we do. But I'll start by saying what you will not be doing at Safran as a data scientist. I think it's important, right? So some people say, what I'm going to do, but I'll tell you first what you will not be doing. So pay attention to this because it's important, so that you're not disappointed later. You will not A/B test for clicks, click rates. You will not be doing that at Safran. You will not build recommendation systems for shopping carts. That's not how we sell our engines or products. You will not scrape social networks for placing advertisements. We will also not be doing that. Instead, what we will be doing at Safran is applying Bayesian networks to create causal models of complex systems. You see, when somebody calls us from a production line and asks to solve a problem, it doesn't help for us to take the data, run the model, and come up with a prediction of how many parts will be produced at a certain quality level. That's not the question. Our models need to not only predict, but they need to integrate the information of what caused a certain effect. It needs to integrate causality in the model. Inference is key. You'll not be doing only, or mostly black box, for better predictions. Another thing that we'll be doing is pioneer the use of unsupervised deep learning in manufacturing. By now, we understand very well how to use deep learning to classify puppies, dogs, ponies, unicorns. So we know how to do that. All we have to do is to give lots of labeled images to the algorithm, and the algorithms will produce this classification for you. The challenge is how to apply these techniques in situations in which you don't have labeled data, or the labeled data that you have, it's of low quantity. Because remember, we are in an industry of high quality, low failure rate, sometimes zero failure rate. So how do you train these models now? How do we apply these models? So if you want to explore there, if you have good ideas, that's the place. You'll also be creating Monte Carlo simulations to design better maintenance contracts. When you take a data set and we look for signals, so let's talk about the service use case again. We look at signals that show degradation of a certain part, a certain component. So that's one job that we do. But then, if you're designing contracts for service, maintenance contracts for clients, that's not enough. The clients will use the airplane sometimes to go to the North Pole, sometimes to the South Pole. Sometimes, they go to the Mediterranean. Sometimes they go to tropical areas with very different conditions. And this will have an impact on the degradation of the product, right? So you'll be using then techniques, simulations, to be able to quickly figure out how a certain client or the behavior of a certain client will impact maintenance services and the contracts. And many more, right? So those are just 3 examples. So you'll be doing and working on real problems with impacts to our economy and to the life of people that travel, and everyone travels, right? Because you'll be, in essence, creating better flying machines with us. And I wanted to show you this short video of the role of analytics at Safran. Right. So could please start the video?
30 cm de haut, 3,5 kg, capacité de vol, 3 secondes. Pas de doute, c'est une poule lambda, qui a un rêve un peu particulier. Apprendre à voler pour remporter la prochaine compétition du volatile le plus endurant. Impossible, me direz-vous? Eh bien non. Grâce à l'analyse de données, cette équipe d'experts va vous prouver que tout est possible. Pour rappel, une donnée, c'est une information qui peut être de différentes natures. Un chiffre ou des chiffres. Un tableau, une vidéo, des photos, des enregistrements sonores, des souvenirs, des odeurs, des articles de presse. Bref, vous avez compris. C'est parti. Et nos experts, qu'on appelle data scientists, vont respecter une méthodologie précise. Tout commence par l'analyse des besoins. Nos experts ont bien compris l'enjeu. Ils doivent accompagner notre pool et réaliser l'impossible, la faire voler. Mais pour réussir cet exploit par l'analytics, ils vont devoir recenser toutes les données nécessaires pour identifier les caractéristiques qui lui permettront de réaliser son rêve. Mais lesquelles ? Quoi chercher ? Où chercher ? Et trouver des solutions pour les données qui n'existent tout simplement pas. Maintenant, passons à la collecte des données de notre pool. Poids, variété de poules, vitesse de course maximale, fréquence de battement d'aile, densité du plumage, taille des pattes, masse musculaire. Mais également d'autres données extérieures comme des résultats de tests antérieurs, les conditions d'élevage, le type d'alimentation, la localisation, la météo, qui pourraient servir pour la suite. Qui sait ? Mais hop, minute, stop. Ça fait déjà un paquet de données qui seront exploitables à condition d'être bien rangées. Roger, tu sais où j'ai posé les données sur les battements d'ailes de poules d'Europe de 1975 à 2018 ? Alors, un stockage structuré, sécurisé et mis en place et un partage simple, accessible est pensé pour que nos experts puissent accéder à toutes ces données où qu'ils soient. Passons à l'exploitation. Ici, nos data scientists vont croiser les données et développer des algorithmes complexes pour identifier les caractéristiques qui pourraient permettre à notre poule de s'envoler. Pénétration dans l'air, aérodynamisme, répartition du poids. Super, une corrélation est trouvée. Toutes les poules élevées en plein air ont un sens de l'orientation plus développé que les poules élevées en batterie. Ils découvrent également que la répartition de son poids et la puissance de ses muscles empêchent notre poule de prendre de la hauteur. Ajoutons-lui des lunettes pour améliorer son système de guidage et créons un moteur à battement d'aile qui devra peser moins de 300 grammes. Réduisons son poids de 20% et augmentons la puissance de ses battements d'aile pour compenser son poids. Sachant que son poids augmente par jour de pluie, attendons le soleil pour faire notre premier test. Parfait, toute l'équipe a l'air satisfaite. À présent, disposons la poule au-dessus du vide et... testons. Et voilà, elle vole, en route pour la compétition. Comme vous le voyez, grâce à l'analyse des données, tout est possible. En 2015, Safran a créé Safran Analytics, une entité qui a pour mission de développer toutes les activités du groupe dans le domaine de l'analytics. En appliquant ces méthodes, des experts de la donnée révolutionnent déjà les process et les produits d'entreprises de tout secteur. Pour chaque besoin, pour chaque problématique, l'analyse des données peut trouver des solutions. Et vous, avez-vous une poule à faire voler ?
Great. So let me finish now by giving you a few reasons why you should join us. If you're a data scientist here, I'll give you some reasons why you should join us. First, you will be a pioneer of the digital revolution in our space. All this technology that we have nowadays, Industry 4.0, blockchain, big data and analytics, those are just components. It's you and us working together that will make this work. As the pioneers in the past, they put together wings and ways of propelling a device to fly, you're going to be a pioneer of this digital revolution. You bring benefits of flying to more people more often. So remember this if you join us. Next time, I promise you, next time that you're in an airport, you enter an airplane, you're going to know the engine, you're going to know everything that's around the landing gear, and this you're going to look around and see how your work impacting society and your life. You're going to grow with us. Safran Analytics was created in 2015. It's just our 4th year. We have a lot of roads to go ahead, and you're going to grow with us. And you're going to learn much more than data science, as I mentioned. Right? You're going to learn about aerospace. You're going to learn about engines. And you say, OK, great. Where should I apply? So 2 ways. You go here, get your cell phone, your computer, go to this website, look for jobs, data science, data engineer. There are several positions in different levels. And the second way, we are here in booth number 5. So just come, have a chat with us. I'm looking forward to hear from you. Okay, thanks. And we still have 25 seconds for questions. But if you cannot ask a question here, number 5.
Hello, thank you for your presentation. Just how many people you're going to hire on 2019? What type of profile and how difficult is it to find them?
I'm sorry, I couldn't understand your question.
How many you're going to hire next year?
So we have, again, different positions and we have different numbers. I cannot give you all the numbers, but for data scientists, we are looking at the order of 5 to 10 people.
Okay. How difficult is to find a good profile?
How difficult?
How easy?
It's always complicated to find a good fit. But we have received lots of very qualified. We have a very qualified team. It's challenging.
Okay, thank you very much.
All right. Okay, thank you again.